Okay, question 15 here. You're told to set up simultaneous equations. If you're told to do something like that, do it, and they tell you let the probability of A intersection B equal Y, and let the probability of B equal X. So we're given this probability of A given B, which we know is the probability of A intersection B over the probability of B. And the probability of A intersection B is not given to us. That's what we're told to equal Y. And the probability of B we're told to let it equal to X. And that's equal to 0. No, we don't have a value for that, do we? We have 0.75. We do 0.75. So 0.75 times X is equal to Y, or 3X over 4 is equal to Y, whatever way you feel comfortable doing it. Okay, what else have we got? Well, we know that the union, I think this should help us here. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of the intersection. So from up above, A union B is 0.6, A is 0.5, B we said we were going to let equal X, and we have minus the probability of A intersection B, which is what we called Y. So we have minus Y. So we just need X in terms of Y, or Y in terms of X. We can replace this Y here with 0.7x, bring the 0.5 across. I'm going to get 0.1 is equal to X minus Y. X minus 0.75x. We're dealing with decimals here, so I'll leave it in decimals. 0.1 is equal to 0.25x. So 0.1 over 0.25 is equal to X, or 10 over 25, which will be 2 over 5, or 0.4. So that's X. So Y has to be 0.4 by 0.75, and that gives Y to be 475 is 300, 0.3 for Y. I think we were just asked the probability of B, which was X, so we actually had our answer down here. But if they had asked for Y, obviously just sub back in. Okay, let's have a look at question 16. Question 16, okay, we're given the diagram, given that the probability of B given A is a half, B given A is equal to the probability of B intersection A, sorry, in the middle that's an intersection, over the probability of A, that has to be equal to a half. So we have the intersection 0.2 divided by the probability of A is equal to 0.5. I'll change them to the same units, decimals or fractions. So 0.2 divided by 0.4, so the probability of A is 0.4, which would leave X to be 0.2. That's easy enough to get X. And then Y is just a bit on the outside. 4 and 2 and 3 is 9, so that would leave Y to be 0.1 in this case. Not 0.1, right in this is 0.2. I'm adding in the 2 twice. 2 and 2 is 4 and 3 is 7. So what Y will be 0.3. We want the probability of A given B is equal to the probability of A intersection B, which we have as 0.2 over the probability of B. So 0.2, and then my probability of B becomes, well, it's 0.5. So that's equal to 0.4. That's all they ask here, so it's straightforward enough. 15 and 16. Okay, practice these questions.